let's take a look at slope fields. So we're gonna look at example 5 in the book on page 407. Now, we've dealt with slope fields before, so we're coming around to it again. And this time, we're going to make our own. And we've worked some examples in the past where we would make our own, and this time we're going to do that again. So, I have written here for you to remember that y prime, or dy dx, whichever way it's given to you, is the slope of the tangent line. Whenever you forget that derivative equals slope, you're in danger of veering off course, okay? So use the fact that y prime, or dy dx, is the slope, so use that as a formula to find the slope at any point. So when you were in Algebra 1, or even before maybe, you made XY charts to find ordered pairs on lines. Well, now make an XY, Y prime chart to find what the slope of the tangent line is at different ordered pairs. All right? So, for instance, here in example 5, they want us to sketch a slope field for the differential equation y prime equals 2x plus y. And then once we have the slope field, we can use it to sketch a solution that passes through the point 1, 1. So the first part is to make a table. Okay? And look, it's not all filled in when you start. Yeah, it's not magic. The numbers don't just magically appear in the correct place. Or do they? All right, so, for instance, you've got to pick the x and the y. You've got to pick both members of the ordered pair. So, whenever x equals -2 and y equals -1, use your derivative to find y prime. So, you would substitute -2 right there for x, you would substitute -1 right there for y, and you'd simplify it, and you'd get -5. So that means that at the point, -2, -1, so -2, -1, so the point right there, you need to make a little, in the book it's always blue, so I'll keep saying that even though we're not going to make ours blue. You make that little blue segment and you try to give it a slope of -5. And I say try to because, you know, it's not real easy to make itty-bitty slopes of -5. Then you pick another point, and they kind of didn't go in the order I would have, but so x equals -2, then they decide, hey, what happens when y equals +1? So we're talking about the point -2 positive. So that point right there is the one we're trying to get the slope of. You put a -2 in for x, you put a +1 in for y, you get -3 for the derivative. So you get -3 for the slope. So they tried to make a slope of -3 there. Okay, if you can maybe tell it's a little less vertical than the one they called -5. So you do that for, I don't know, a couple of hundred points. You get a couple of hundred little blue lines. Then, all right, so it says next draw line segments at the points with the respective slopes. That's what we've been doing. And then finally, once you have your slope field, after the slope field is drawn, start at the initial point 1, 1, because that's the one they told us to make the answer go through. So you start there and move to the right in the direction of the line segment. Continue to draw the solution curve so that it moves parallel to the nearby line segments. Then you do the same to the left of the point 1, 1. Okay? So, and it's, I mean, that's kind of, I don't know, that's not very precise, right? When they tell you to you know, so that it moves parallel to the nearby line segments. We've had better directions than that before, okay? But that's what you do. So you start here, then you see the little blue slopes, and you try to make your graph have the same slope as the little blue slopes near it. Then you do the same thing here. And next thing you know, you have the graph of a solution. Okay? All right. I like the note here. Drawing a slope field by hand is tedious. Really. In practice, slope fields are usually drawn using a graphing utility or copied out of the book. Sometimes we do that. Okay? So they're acknowledging the fact that making slope fields by hand is not the most fun thing you've ever done. Quite often on the AP test, you have to make one by hand. Now, it won't have 2 million little blue lines. It'll give you like 16. Okay? So what they'll do is they'll show you a coordinate plane, and they'll fill in the points they want you to figure out, and then we'd come in and, you know, however it looks, and fill the rest in. Okay? So, I mean, because you got to get that problem done in 15 minutes to stay on pace to finish the test. So they can't make you do a whole bunch of them, but they can make you do a few. Okay? All right. Let's take a look at number 46. It says, use integration to find a general solution of the differential equation. Now, this is more like what we've done in the past. Okay? So we're given a differential equation. It's called that because there's a derivative in it. So dy dx equals x times the square root of 5 minus x. Then let's multiply both sides by dx, and let's integrate both sides. The integral of 1 dy is, in fact, y. So y equals the integral of x times the square root of 5 minus x dx. All right. You've got a whole bunch of techniques that you know how to use now. What are you going to guess to let u equal? Yeah, 5 minus x is what I would have guessed too. Try it. Oh, I kind of tipped my hand, didn't I? How about if we let u equal the square root of 5 minus x? If that's the case, what does du equal? Negative. Finally, somebody said the negative. If this is our u, think of that as 5 minus x to the 1/2. Then the du is going to be 1/2 u to the negative 1/2 times the derivative of u. And the derivative of negative x is negative 1. So we can get I'll put the negative with the 1 up there. Got a negative 1 over 2 square root of 5 minus x. Oh, guess what I left off? Dx. So that's what du equals. Not exactly what we had hoped. So naturally, I'm going to multiply both sides by negative 2 square root of 5 minus x. And you know why I did. Gets dx by itself, and what does it get on the left? Because it looks bad, right? You got x's and du's, negative 2u. The square root of 5 minus x is u, so replace the square root of 5 minus x with u, and it's a negative 2u du. That's useful. That was the magic. Okay. Now, let's see what it would look like if we did the substitution now. So we have the integral of. All right, so the square root of 5 minus x, that's u. Dx is negative 2 u du, but I still have that x there. Just ignore it. Hope it doesn't really have anything to do with the problem. All right, that's one strategy. Let's see if we can come up with one that might work. Charlie?
Oh my God.
Go back there, solve it for x. So, square both sides. Subtract 5 from both sides. Multiply both sides by a negative 1. So it turns out that x is going to be replaced by 5 minus u squared. So instead of that, x 5 minus u squared. And we've made our substitution, haven't we? Can we integrate what's left? Yeah, we have to simplify it a bit first, but we sure can. All right, so y equals, because remember, it's a differential equation. We got y on the left. Y equals negative 2 times the integral of 5 minus u squared times u times u times du. And if we think of u times u as u squared, and then we distribute that u squared, we get y equals negative 2 times the integral of 5u squared minus u to the 4th du. And that we can integrate. So, y equals negative 2 times. Then take the antiderivatives for 5u squared. Add 1 to the exponent, make it a u to the 3rd. Divide your coefficient by the new exponent, so 5/3 u to the 3rd. Then for the negative u to the 4th, add 1 to the exponent. It's a u to the 5th. Divide by 5, negative 1/5 u to the 5th, plus c, and we're done. Yeah, we're not done. We need to replace u with the square root of 5 minus x. And shall we distribute that negative 2? Either way, I did. So, any integration technique we've ever used is fair game. Yeah. Ooh. Plus. Good catch. All right. Anything else on 46? Let's take a look at 51. All right, on this one, the directions say, in exercises 49 through 52, a differential equation and its slope field are given. Determine the slopes, if possible, in the slope field at the points given in the table. So I really wish they hadn't even given us that. We don't need that, okay? But what we have then is they've picked out the points for us that they want us to figure out what the derivative equals, okay? So, and this is the way the AP test does it. All right, they'll tell you, well, in the past, they've told you the points. Now, what I remember them doing is like I showed you before, where they'll just have little dots at the points they want you to do. But I don't know, maybe they'll start the table for you. Who knows? It's always, whenever you think you've got them figured out, you're wrong. They'll do something a little bit different, okay? So, we're going to fill in the table is what we're going to do, okay? So, copy down the table. So we have dy dx equals x times the cosine of pi y over 8. And they want us to find what the derivative equals, what the slope of the tangent line equals at negative 4, 2, negative 2, 0, 0, 4, 2, 4, 4, 6, and 8, 8. All right, y'all ready to get started? All right, so we're going to use this differential equation to decide what the slope is when x equals negative 4 and y equals 2. So replace x with negative 4 and y with 2. So I should have written here dy dx equals, so I replaced that x in the front with the negative 4. Then I have the cosine of pi y over 8. So pi times 2 over 8. Well, 2 pi over 8 reduces to pi over 4. All right, so what's the cosine of pi over 4? So I've got negative 4 times the square root of 2 over 2. Negative 2, square root of 2. Now, I'm going to stop there, but if I'm actually going to make that little slope, I'm going to have to convert that to a decimal, aren't I? Okay? I don't really know how to draw a slope of negative 2 radical 2. Okay? But since they've already drawn the slope field for me, I don't really have to convert it. If it's bugging you that it's not converted to a decimal, go ahead and convert it. All right, now, let's do the same thing for the point negative 2, 0. So, and again, I should have written dy dx equals, and then replace the x with a negative 2, cosine of, replace the y with 0, so that'd be the cosine of 0 over 8, which is the cosine of 0. What is the cosine of 0? So I've got negative 2 times 1, and that slope is negative 2. Yeah, try that next one on your own. They probably picked ones that we can actually simplify. Nope. And the thing is, if this were on the AP test, this is most likely not on the calculator section. They're going to expect you to know the values of cosine at those places. What'd you get? Yeah, me too. All right. Again, I should have written dy dx equals. All right, do the next one. I got 0 again. Did you get 0 again? All right, finish it up. Did you end up with the same things I did? Okay. So, tedious, yes. Impossible, no. And think how easy this would be if that were an algebraic derivative instead of one with a trig function in it. Okay? I mean, this would turn into a really easy problem. Okay? All right, any questions? All righty. So on page 410, do 37 through 56.